Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. In the last session, we have solved some problems on discrete random variables and discrete probability distributions. And today, I would like to discuss some problems on continuous random variable and continuous probability distribution. So, a random variable is said to be discrete if x takes finite number of values, A random variable is said to be continuous if capital X takes infinite number of values. So, in the case of a discrete random variable, we use sigma notation to represent the sum of the probabilities, whereas in the case of continuous probability distribution, we use sigma notation. And now, let us discuss some problems on continuous probability distribution. Now, let us consider this problem. A random variable capital X has the following probability distribution. So, the probability function is given here, f of x is given, where f of x is 2 into e power minus 2x when x greater than 0. X greater than 0 means up to infinity. That means x takes infinite number of values. So, this is a continuous probability distribution, and this probability function is called density function. So, the function exists when x greater than 0 and 0 in all other cases. That means x less than or equal to 0. Now, find the probabilities that it will take on a value between 1 and 3 and greater than 0.5. So, we need to find the probability that x lies between 1 and 3. Similarly, x greater than 0.5. So, here coming to the solution, first consider the given function, which is 2 into e power minus 2x when x greater than 0 and 0 otherwise. And to find the probability that x lies between 1 and 3, so 1 less than x less than 3. So, which is integral from x equal to 1 to 3 f of x dx. But the function is defined for all x greater than 0 values. So, 1 and 3 comes under x greater than 0. So, the function is 2 is a constant, e power minus 2x dx, and we need to integrate this from between 1 and 3. So, this is e power minus 2x, integration is again e power minus 2x by minus 2, and here multiplied by 2 from 1 to 3. So, these 2 gets cancelled. So, upper limit e power minus 6 minus, again here we have one more minus sign. So, e power lower limit is 1. So, minus 2, and here minus into minus, that is plus. So, the answer is e power minus 2 minus e power minus 6. Probability of x lies between 1 and 3 is equal to e power minus 2 minus e power minus 6. We can find the numerical answer using a calculator also. And next, probability that x is greater than 0.5. So, the second question, probability of x greater than 0.5. So, that means x from 0.5 to infinity f of x dx. We need to find this value, but the function is defined for all x positive values as 2 e power minus 2x. So, 0.5 to infinity, all the values comes under positive values of x. So, 2 into the function e power minus 2x dx from 0.5 to infinity. So, integral of e power ax is again e power ax divided by a. So, e power minus 2x divided by minus 2 from 0.5 to infinity. So, here these 2 gets cancelled, and for upper limit minus e power minus infinity, for lower limit minus into minus plus e power minus 1, and this is 1 by e power infinity. As e power infinity tends to infinity, 1 by e power infinity tends to 0. So, this first value is 0 and the second one is 1 by e. Hence, the probability of x greater than 0.5 is 1 divided by e. Now, coming to the next problem, the probability distribution function of capital X is given by, again another function is given. So, f of x is k into 1 minus x square when x lies between 0 and 1, when x lies between 0 and 1, 0 less than x less than 1 and 0 otherwise. And find the value of k. The first question is to find the value of k. To find the value of k, again we use the property that the total probability is always unity equal to 1. That means, here x is the continuous random variable and the distribution is continuous distribution. The total probability is denoted by integral minus infinity to plus infinity f of x dx. This value must be equal to 1. And now integral minus to plus, but the function is defined between 0 and 1 only. So, this minus infinity to plus infinity, we need to split this integration into 3 parts: minus infinity to 0, plus 0 to 1, plus 1 to infinity f of x dx. So, we split this integration into 3 parts. This is equal to 1. Now, minus infinity to 0, so otherwise only between 0 and 1 the function exists. At all other places it is 0. So, this is 0 plus k is a constant, integral 0 to 1, 1 minus x square dx, plus again 1 to infinity 0, 1. So, by integrating, integral dx is x minus x cube by 3 from 0 to 1 is equal to 1. So, from this we can calculate the value of k as so upper limit 1 minus 1 by 3 is equal to 1. So, k into 3 minus 1, 2 by 3 is 1. That implies the value of k is 3 by 2. Now, we can replace this value in the given function also. So, here we have obtained the value of k as 3 by 2. Now, the first one is over. Now, we need to calculate the probability of x lies between 0.1 and 0.2. Now, coming to this second problem, probability of x lies between 0.1 and 0.2. 0.1 and 0.2, integral 0.1 to 0.2 f of x dx. So, here 0.1 and 0.2 comes under positive values. So, k into 1 minus x square, that is the given function. So, k into 1 minus x square dx, but just now we have calculated the value of k as 3 by 2. So, 0.1 to 0.2 1 minus x square dx. So, again by integrating, here we get x minus x cube by 3 between the limits 0.1 and 0.2. So, if you substitute this, you will get 0.1465 is the probability that x lies between 0.1 and 0.2. Similarly, the third question, in the third question we need to find probability of x greater than 0.5. X greater than 0.5 means integral from 0.5 to infinity f of x dx. So, 0.5 to infinity, all these values comes under positive. So, k into 0.5 to infinity 1 minus x square dx, simply by integrating the given function between the given limits. That gives the probability that x greater than 0.5 or less than some value, or x lies between any two values like 0.1 and 0.2. So, here again by integrating, so here k is the value of k is 3 by 2, and integrating we get x minus x cube by 3 from 0.5 to infinity, and again here we get the final answer as 0.3125. So, the given, if the given function is the probability density function, that means the probability distribution of a continuous random variable, then to find the probabilities between x lies between any two values, we use this integral notation, since this is a continuous case. Similarly, let us consider this example. The probability distribution function of capital X is given by f of x equal to 1 by 2 sin x, where x less than 0 less than 1, 0 otherwise. So, the density function is given, and find the mean, median and mode of the distribution. Also find probability of 0 less than x less than this pi by 2. So, here we need to find the mean, median and mode. So, what is the mean? mean mu is the expectation of x, which is given by integral x into f of x dx from minus infinity to plus infinity. So, here f of x is given as 1 by 2 sin x, and minus infinity to plus infinity, it is not mentioned, it is given when x lies between. So, here in fact these values are 0 less than x less than pi half sin x and 0 otherwise. So, 0 less than x less than pi, these are the values of x lies between 0 and pi. Now, to find this half into, since the function is defined between 0 and pi only, so we can directly consider the mean as 0 to pi, the function is sin x multiplied by x, x sin x. Here we can use the integral by parts, integral f of x into g of x dx. We have the property or the formula, f is the first function, g is the second function. So, f of x first function into integral of second function minus derivative of first function, again integration of second function plus second time derivative of first function, third time integration and so on. So, here plus minus alternately changes, and we always differentiate the first function and integrate the second function. So, here x is the first function, sin x is the second function, and by using that, this is the first function, integral of sin x is minus cos x, minus derivative of x is 1, and again integration of this minus cos is the minus sin x, and again the derivative of 1 is 0. So, the formula terminates here from 0 to pi, and since here we have the sin function, sin n pi is 0, since sin n pi is 0, sin n pi is 0, this second term completely 0. For lower limit here we have into x, so that is also 0. So, half into minus cos pi, only this value remains. So, from 0 to pi, here the upper limit is pi, lower limit is 0. By applying the upper limit here, pi into here x, in place of x we need to substitute that. So, minus, here I can use the minus sign. So, minus here and pi cos pi, and we know that cos pi, what is the value of cos pi? Cos pi is minus 1. So, minus half into pi into minus 1. So, hence the value is pi by 2. So, the mean mu is pi by 2. Simply the mean is calculated using the formula integral x into f of x. Now, let us find the mode. Mode. What is mode? The point x at which f of x attains its maximum value. Mode is the value, or mode is the point at which the function attains its maximum value. Now, what is the given function? F of x is half into sin x. And how to find the maximum or minimum value of a function of single variable? First, we need to calculate the first derivative of f and equate it to 0. So, consider f dash x equal to 0. Now, what is f dash x? The derivative of f, half cos x. So, half into cos x is 0. That implies cos x is 0, and when the cos will be 0? When the angle is pi by 2, cos 90 is 0. That implies x equal to pi by 2. So, at this point, we need to prove that the function attains its maximum value. To show that, we need to find the second derivative of f. Now, what is the second derivative of f? Minus half sin x. And let us substitute this point here, and this is minus half sin pi by 2, sin 90 is 1. So, if the second derivative at pi by 2 is less than 0, then at x equal to pi by 2, the function attains its maximum value. So, that is the procedure of finding maxima and minima of a function of single variable. So, here the mode is the point at which the function attains its maximum value. Here this function attains its maximum value at x equal to pi by 2. Therefore, the mode of the distribution, mode of the given distribution is also pi by 2. Already we have calculated mean, that is pi by 2, and mode is also pi by 2. Now, let us calculate the median of the distribution, the third one. And we know that the median is the point m, median is m, where integral a to m f of x dx is equal to m to b f of x dx is half. Median divides the entire distribution into two equal parts. So, here that implies integral 0 to m f of x dx is equal to integral m to pi f of x dx is equal to half, because the function is defined from 0 to pi only. So, let us consider any one of these two values, or that implies half into integral 0 to m. The given function is sin x, half sin x, which is half into m to pi sin x dx, which is half. So, simply these two values gets cancelled, and integration of sin x is minus cos x between 0 to m, which is minus cos x from m to pi, and here the values are cancelled. So, 1 we will get. That implies, let us consider any one of these. Cos x from 0 to m is equal to 1. So, the upper limit and lower limit after applying minus cos m minus plus cos 0 is equal to 1. For lower limit we will get negative sign. So, the second term will be positive, and cos 0 is 1. So, 1 minus cos m equal to 1. That implies 1 minus 1 is cos m. So, cos m equal to 0. When cosine function vanishes, cosine function value becomes 0 when m is pi by 2. Cos 90 is 0. So, cos m will be 0. That implies m equal to pi by 2. So, the median of the distribution is also pi by 2. Hence, the mean, median and mode coincides for the given distribution, and we got the answer as pi by 2 for the given distribution. And coming to summary, in today's session we have solved some problems on continuous probability distribution and continuous random variable. In continuous probability distribution we use the integral notation, and the total probability in the case of continuous probability distribution is integral f of x dx is 1 from minus infinity to plus infinity. Using this property we can find the unknown value given in the probability distribution. Similarly, to find the probability that x lies between any two values can be calculated using the integral notation. And in the next session we will discuss the different probability distributions, like there are two types: discrete probability distribution and continuous probability distribution. In discrete probability distribution we have two types of distributions: binomial and Poisson distribution. In continuous, normal distribution, t distribution, chi-square, f, etc. So, in the next session we will discuss about these discrete probability distributions and continuous probability distribution. Thank you very much.